So we will talk about technology because tomorrow we will have another roundtable to talk more in the business areas. But well, about technology, I think that the Alan Gate presentation was really good because we have seen how Hadoop was evolving and what big data is now. And we have different people from Teradata, machine learning, Mesos, Hortonworks. So I think we have also different opinions and contrast. So in general, what would you say now, this year, was the big deal or the hot topic, if you have to say just one? Okay, it was the resources managers. It was, of course, you will say so. No, machine learning, this edge or data in movement, the fast data processing. What would you say is the hot topic? Only one this year. You have to choose one.
I think analytics and engineering, that's still the hot topic. So how to put together actually the data science together with those tremendous chain of tools. So I don't know if there is a word for it. So something like analytics ops or engineering for data science. I think that is still one of the things which is being asked over and over again. So how actually do you combine and you create those recipes? And all the rest is also cool, and of course but this is for me still one of the things that in the industry is still very much sought for.
I would represent about machine learning, of course. I think that this has been a lot of breakthroughs.
You can choose whatever you want, Paco.
But to be fair, I mean, coming from O'Reilly and seeing what we're seeing, talking with our customers, talking with our authors and our audience, I would also say that I think it's a lot about ops, a lot about DevOps being really a bottleneck, the operational part. We know how to write good code, application code, but how do we get that code out to the customers? How do we take action on data and get it out, have the customers use it? And like what Alan was showing, working in the cloud, being able to stand up a cluster on need, I think that ops has really been kind of some big areas identified where there can be breakthroughs. But that's a lot of the transformation that we're seeing in enterprise now. It's the thing we hope will break through.
I would probably pick, oops, maybe I'm on, maybe not.
No. Is it?
Not yet. I can. Number 4. Am I number 4?
Number 4?
Maybe. Do I have?
Well, if you want, we can move and you can fix this.
Okay. Go for it.
Hello? Okay. I'm number 3. Oh, yeah, so that's why you guys made us switch, right? Because we were... Yeah, I mean, I'm out and about quite a bit, doing a lot of meetups and conferences and just talking to people. This is great being on stage, by the way, with, these are some of my idols here. Yeah, Paco doesn't know this, but I've been following him, sort of creepily for the last, 5 years. But seeing, I guess, right, like quite honestly, and this is almost trite at this point, but just seeing TensorFlow take off, right, and seeing, like, I'll come speak somewhere and have something about Spark and something about TensorFlow, which is the meetup I run out in San Francisco, is both of those. And at this point, no one really cares about Spark anymore. Or they do, but they can read that in the 5,000 other blog posts that are there. So they want to hear more about TensorFlow. And like getting those Google guys to come out, they're still in that sort of early phase where the current developer advocates come from the cloud platform side, and they know their services and Bigtable, but they don't really know the TensorFlow side of things. So there's this big gap in like knowledge right now, and I think that kind of fuels into why people are so excited about it. So yeah, and just talking with the O'Reilly people, they're trying to get more and more TensorFlow authors in there. So that, and I think just, right, like platforms and sort of the infrastructure, you know, seeing Uber building the same thing Apple's building, seeing the same thing, you know, and they aren't going to open source the platform, right? So this is, you know, something us with PipelineIO, the company I just started last summer, that's what we're focused on, is kind of, you know, building that out. I just talked to the Quora guys. They're also building out the same machine learning platform where you can deploy it out, build it, train it from a notebook, push it out kind of thing, you know, scale it out.
Okay. So Alan, I think now, is it working?
Am I on now? Maybe?
Yeah?
Is Cloudera running these mics? All right.
So,
Okay, so I would, like I talked about that data in motion, the ability to get data at the edge and move it in. I would say for us and our customers, that's one of the hottest areas we're seeing, one of the biggest areas of growth. And to cheat a little bit and tie it into what you guys were saying about ops, I think in that streaming stuff we see, and in our regular data, we see a huge push on self-service. How can people who have access to this come and get it without having to go through some 5 steps of approval to get to that data, right? And that applies to the streaming and the data at rest, I think.
fantastic.
All right. Is that microphone on?
Yeah,
Yeah.
maybe no.
Okay. Sounds good. All right. So 2 things. Okay. You guys already did half of my talk, so I don't need to go into that anymore. If I would be boring, I would also say, you know, exactly that, like TensorFlow, machine learning stuff, that is really like the big thing. But as this has already been talked about, I will go for IoT. And in a sense that if you think back a couple of weeks ago, what happened with Dyna, that essentially a botnet, you know, that was made out of, you know, surveillance cameras and whatnot, took down quite a large part of the internet because the DNS servers and so on were not available. This is the first time, at least to me, where people kind of realized, oh shit, there's something going on that is way beyond our control, and maybe this gives us an opportunity to think about, you know, harnessing that for something good. Obviously, that was a bad example, but to me, that is something like, okay, first time that IoT really showed off, okay, there's something more beyond the traditional, you know, slide decks and whatever. Yeah.
Okay, there is, I think, a hot topic this year too. A lot of people here, they are using it in some way or another, and it is all this about the OpenStack and Elastic with this Dockers and Kubernetes stuff, Mesos and Yarn, and how they can coexist or cooperate together. What is your vision? When to use one? When to use it with another one? What are the problems for Dockers with data storage or distributed data, the same in the Mesos, maturity and all this stuff? What is your opinion? When to use it? How to cooperate between them? Recommendations? So anyone can start. It is a difficult topic, so.
I mean, it's counterintuitive, but as a publisher, we work with authors, and you know, we do a lot of work coaching authors to put code in like the first paragraph of the first chapter of your book. And historically, we've always published a lot of code, but you didn't necessarily have it running. It's up to the reader to figure out how to get the code to execute. And what we're seeing now is where there's a big shift of having the authors use containers, use them on a desktop platform to actually be authoring in the context of a container so that you can prove that your code works, so that you can have somebody else just go and execute it right away and say, oh yeah, that's valid. And you have all the libraries there, you have all the data there, everything's nicely packaged so that you know, the next time I read a book, I don't have to go and completely reconfigure my laptop to install different libraries just because I'm switching from one book to another. So I think that there's a real revolution in terms of personal usage of containers, but then also being able to cross that bridge and take what you've done personally in your own workspace and move it out into, whether it's on-prem or in the cloud, move it out onto larger infrastructures such, as you were saying, there were several, whether it's running in Yarn, whether it's running in Mesos or OpenShift or whatever, but making that transition from developing things locally and then pushing out and running it at scale.
Yeah, I'm convinced, I agree, and I'm convinced that it's not a zero-sum game. So if you look at any reasonable big company, they will have different technologies. They might use, a Yarn cluster for that. They might use a Kubernetes cluster for that, and a DCOS cluster, hopefully, for something else. So it's a bit like paella. As long as you don't put chorizo in there, you're good, right? So you have all these mixtures. You put everything in there, and everyone is happy, right? There will not be one technology that dominates all. There will not be DCOS dominating everything, or Kubernetes, or whatever. I believe strongly this is not a zero-sum game.
Yeah, I mean, I think this year was a pretty big year in terms of, there's now, like native Docker for Mac, so that you don't have to install VirtualBox and do all these tricks and things that even, seasoned people couldn't get that stuff to work, right? There was a lot of networking issues, and if you had a different version of VirtualBox for like another project for some training class you took, that would screw everything up. So we have that now. We have Docker for like Windows, which is native, I think ish. Is it pretty native? Someone told me the other day it's not purely native, but yeah. So, but it's still like much easier to use. There's things like Minikube where you can run Kubernetes locally. We're talking to these data science groups that explain their problems where they have a local environment that has like different versions of Python, and they're like upgrading Matplotlib and like scikit-learn. They go to push that out behind their Flask service to actually deploy it, and that has a different version of HTTP requests and things like that. So the ability to actually like not just run the same Docker image locally, but the whole like cluster locally with like things like Minikube. This is very powerful.
Yeah, and on the Yarn side, I mean, we're seeing the same thing. People have their applications already. They have a Docker container, and a lot of work is going in Yarn and Hadoop 3.0 to just run those natively, so that it can be yet another place to run those containers. And I agree with you. It's not like it's not like Yarn's going to rule the world because now it can run containers. It's just we know people are already using those containers. They want to put that on their Hadoop cluster, and we want to make that work.
Okay. There is another topic that most of the people, developers here in Europe, ask is this. I think Paco was explaining something about this. Is the meaning of the data. In big data, some of the data, or in some cases, most of the data is unstructured data, so you have to give meaning to the data. The metadata is really important. Alan was explaining how Atlas and other modules are managing this in a central point. So what's your opinion about this? Metadata is or should have the security, the governance, the taxonomy, the meaning, the business glossaries should be in the metadata. There is, when we are taking off in our company, a discussion, what is more important, data or the metadata? And we are seeing that metadata is almost growing more than the data it belongs to. So where is this going to, and what is your opinion, and how important is this, and how much should it grow? Yeah, especially taxonomies and meaning and all these things. Where should it be?
Yeah, maybe Óscar, I would like to start with that one. So if you look at enterprises, especially companies which operate in financial services or for instance in the telecom, you see that actually there's so much machine-generated data. And next to that, some of those machine-generated data come actually from ETL processes or from data transformation processes, which are actually set up by people, but then very quickly transform actually in more data and more metadata. So in a way, actually, we are creating a sort of a pyramid of metadata built on top of metadata and machines analyzing metadata which produce metadata. And how do you put it all together is, in my opinion, to be honest, one of the ways to solve the problem is machine learning itself. So have actually machine learning analyzing, let's say, this flow of information and extract pattern for it might be the way to go. Of course, it's not a traditional way because we still would like to keep control on this sort of operation. So we are still in the process of having tools for lineage and kind of keeping this sort of pride in understanding how the data works and flows in the organization. But honestly think that indeed the next step for metadata analysis is actually machine learning itself.
So I have a rather strong opinion on that because in my previous life I was a researcher in the semantic web domain, and this wonderful vision of having a web that describes itself and you have links and so on. And lesson learned there was essentially in 2012 or whatever, 11, Google came along and came with schema.org, and essentially everyone's like, okay, there is a clear incentive, right, for publishers. If you put that in, you rank higher or better or whatever. And I think that is the issue. We're creating essentially data swamps, and without the metadata, I'm only aware of one company, Waterline, correct me if I'm wrong, maybe there are others now, that actually focus on that issue, to really give someone who wants to use stuff a tool in their hand to say, like, okay, how can I find data set about this population, this old, in this format, or whatever it is. Not even talking about the more advanced things, machine learning, just the basics, right? And that is a huge, like in my understanding, and I'm happy to learn that there is a new Apache project that addresses that. I don't know, I only know Waterline, that they do that huge gap. I think that's something we definitely need.
So there is an Apache project that at least addresses it for stuff inside your cluster, right? To help you find stuff. It's called Atlas, Apache Atlas, that you can tag and find what's going on there, but it's not going to help you find what's out in the world if that's more what you're looking for, right? Which is kind of a different bent on it. One thing I would comment on your, where should it live? I think maybe we should change the question a little bit to how do I get to it? Because the metadata is going to live in different places. You can't go to every tool on your system and say you must put your metadata here, because you've got a conglomeration of tools and they all maybe think about their metadata differently. But it might be more possible to say, okay, I have an API that can find that metadata for me, whether it lives here or there, or, I mean, as much as I can, it does make sense to put it in a central place because it's easier to manage. But you're always going to have that odd tool that's like, no, I have to hold, like you said, I have to hold my metadata, it's mine. If we can at least put together an API that everybody can agree on to implement, that so that the user doesn't have to worry about that problem. All he has to worry about is, okay, I make this call, I find the metadata, then I do my work.
Yeah, so sort of it doesn't matter where physically the metadata is. It can be in Elasticsearch, Zookeeper, or whatever, but the API is managing as a logical single point.
I mean, there are technologies like RDF and OWL, sort of inheriting from semantic web technologies. There are ways to describe metadata very formally, like Mike was saying, and I think that these are excellent ways to define and provide endpoints. The tools around them are, a few generations back. They really need to catch up. I made that point about how, the people doing triple stores haven't really heard about microservices yet, and that's one thing we could change. I do think it's reasonable to use something like RDFlib in Python and stand up a Flask microservice and have that as an endpoint. So I think that there's a way there. But one of the things about metadata, 12 years ago, I worked in finance, and I was working on the Linux side of Z systems, IBM mainframes. And it was specifically for metadata management for banking problems. And what we would see there, I'll reference my boss at the time was Jack Olson, who used to lead IMS and led part of DB2 for a while. And he wrote a book called Data Quality about metadata drift. And so what we would see was really more of, I think, the peopleware issue that, in the BBVA talk was excellent about the changes on the peopleware side. And so, case in point, you would deploy a large database in a bank or telecom or some large enterprise. And over time, because of all the governance and IT restrictions, the schema for the database would, people couldn't change it. They had to go through too many hoops to get a change. So they would just take a field and start overloading additional values. So you see over time where the metadata would evolve and drift. And of course, the problem in banking that we were trying to solve back then was if you get a lawsuit in the US, you're responsible for the last 7 years of data. But to try to do a query over 7 years of data, it's almost impossible because the metadata has maybe changed 4 or 5 times. How are you going to have a query when the schema isn't stable, how are you going to query it? And so having tools that understand that kind of versioning, even if we can stand up endpoints, how can we really describe the versioning that's behind the API, I think is a critical problem for metadata.
Okay. So I think another of the hot topics that the people was asking is they are using cloud, private and public, and then there are things about this that they are worried about, like latencies, disk storage when you are using S3, how important is to have the data locality in the machine where you are running Hive or Hadoop. What's your opinion right now about that? Is it much better to have it locally or in S3? It doesn't matter. The latencies between a bank for fraud systems and a public cloud is good enough. What's your opinion about this stuff?
I think, there's a whole set of trade-offs, right? You are going to get different performance characteristics in the cloud, and Hadoop is evolving to give you that same performance in the cloud that it can give you on-prem. It's not 100% there yet. But I don't think you should make that decision just on performance. There's also questions, like I talked about, at cost, time to market, all those. A lot of people are concerned about security in the cloud. I think that's an area that really can be addressed now. In the US, much of the intelligence agencies are actually using clouds. They certainly have security requirements. The financial regulators that watch the stock market are using the cloud. They certainly have very strong security requirements. So it can be done, but it's something you have to make sure is done right? Because it's something can also be done wrong, and you don't want that to happen. I don't know that I would think about it just in terms of performance. There's many variables that go into that equation, and you kind of have to balance that for your company. And one thing I know, I've had customers say to me, we're a big enough company, we believe in the cloud, but we believe we can run our own cloud. And that's where private cloud may make sense. Maybe not, I don't know. But that's another thing to put in there is, can I get the benefits of the cloud, the elasticity, the quick response, all that, but still keep it in-house and have economies of scale on my side?
Okay.
Yeah, I think, Alan, Alan? Yeah. Alan, that's a quite good point. I think that, in a way, the fact that we abstract from infra, that's something which is going to happen. And the cloud as a collection of services to spawn machines and tools is probably something which is going to stay. In a way, I think that the point is, how do you prepare for this transition once, for instance, you have teams that want to run their own Spark cluster of different versions, they want to interact and spawn, let's say, their own machines and destroy them for after a period of time. So probably the best way to go is, can we actually set up systems which are already sort of cloud ready, and for those enterprises, start maybe on-premise, but start to use the services, start actually to spawn clusters of computing nodes or storage nodes, and then slowly understand where is the sweet spot between, let's say, the locality as in on-premise versus the distributed clouds, public or semi-public out there.
Right. And to your point, in terms of security, I'm strongly convinced that the AWSs and Microsofts and Google and whatnot, they can provide way better security than any of us could ever in their own data center. I'm very convinced about that. Yes, there might be legal reasons or issues. Sometimes this is a kind of like an excuse, people trying to preserve their jobs, to put it that way. But one aspect we haven't talked about is data gravity. So data has gravity, and if you have, I don't know, 2 petabytes on premises, it's a non-trivial task to quickly, you can quickly spin up a number of VMs somewhere, but you cannot quickly get the 2 petabytes into the cloud or whatever. So this is, and I agree, there are many of these things, not only performance, but data gravity. If you have a concept around that, have a plan around that, then you're fine, right? You can leverage the cloud, the cyber.
There is basic physics, as Mike was saying, about the data. And I love the example that Alan showed about airline engines. It was a few years back, but there was a conversation, and people at GE were looking at how to get this data down into a data center, and they had called up TCS they'd brought in, and I knew friends at GE, but I also had friends at TCS who were like, hey, we're working on this problem, we don't know an answer. And they wanted to take that data from the airline engines and bring it down into the cloud somewhere to do analysis, because if you have a problem with an engine, you have to ground the aircraft, you can't fix it at the airport, you have to ship it off. There's this incredible tool chain to just make a change in an airline engine. And when you look at all the flights in the air at one time, it ends up being like 12 exabytes per day. And so GE was faced with regulatory pressures, and they wanted to get this data as quickly as possible in the cloud. They went to the consultants, they said, how do we do it? And eventually they went back to the people making the sensors at National Instruments, the people who made the IoT sensors on the physical engines, and they said, how do you put this in the cloud? And the answer was physics wouldn't really allow us to do this, not in any kind of real-time sense. So how can we have more of an edge network to be able to work with the data to aggregate it out at the edge and bring it up in stages? And it's a problem of physics, that the more that we instrument it, the harder that we can get the data moved from one place to another.
Yeah, so I come from Netflix, and my first couple weeks there, I couldn't believe that all of the data was in S3, and all of our compute, well, it was still within Amazon, it was on EC2, but I just couldn't get over the fact that the data wasn't on the exact same node as the compute, because that's the whole point of MapReduce. And but they had done their performance tests, and while it was slightly slower, right, because most of the Netflix workloads it was like machine learning and all these CPU bound type things. So if you're CPU bound, that doesn't necessarily affect performance, right? And just the ability to scale out, scale in, I mean, there's huge cost savings with that. There's huge efficiencies with that. So, and just the ability to spin up a cluster real quick just to experiment on that same data and not have to, copy the data over, shuffle it, things like that. So I just became convinced pretty early, but it pops up. Like I was at Databricks, Paco and I were at Databricks for a bit, which has a notebook product with Spark bundled in there that runs on Amazon. And that was always one of the first questions customers would ask is, we're storing our data in S3, why? Yeah, so how is this efficient, between EC2 and S3? And yeah, we would always show them the Netflix use cases and the performance benchmarks. So it just doesn't seem to really outweigh a lot of the benefits of the cloud.
Okay. So I think we are running out of time. Okay. Yeah. I will try to talk about another topic or together with others. Is the data technology has moved to data distributed solutions, and then something similar is happening to the applications with the microservices the applications are moving from monolithics to distributed applications with small microservices. And then I want to relate this or to talk about this together with this, the stateless of the microservices and the data they have, the stateful operations, and also, to complicate more the topic, Kafka against the normal classical middlewares that are using some of the companies like TIBCO or other stuff they were using before. How do you think this all work together when this stateless with the microservices and to be restricted to the classical definition of a microservices works with the distributed data engines or databases? What is your opinion about all this? So who is the brave one to start?
It's difficult. We have a use case right now. There's a new service that's being rolled out for our online library. And it was a big argument because there's a service that we were building that we wanted to make as an immutable microservice. The CTO wanted to make it transactional because he wanted the data to be very closely associated with every access. And we were saying, no, make it immutable, we can scale it, we'll collect the data off of our log files, we'll do log file analysis. So it's a very different mindset of having a transactional data to track versus going back into Kibana or HDFS or wherever your logs are at. And I think people have to be comfortable with using more of the big data technologies so that they can take advantage of immutable services. That's still kind of a bridge to cross.
So one aspect of microservices, as you know, is the idea that essentially you have the local storage in the sense of the microservice itself defines what is the best way to store data. So rather than having one big Oracle box where everyone is sitting on the same schema, that one microservice might use Elasticsearch, the other one might use something else. Kafka you see quite often as a kind of bus there, like a data bus where like everyone consumes and publishes stuff. To me, the aspects there are mainly everything that is open source. You compared it with other established vendors that typically still have closed source offerings. This means not only people can look at the source code and do something with it, but they can also and do bug fixes and whatnot. But they take that and add stuff in the sense of they come up with a new algorithm or whatever and bring that back to the community. And that is something to me that is really, really important, that you have this quick feedback loop and you evolve in a typically much faster than proprietary solutions.
Okay.
Yeah, I'm just thinking, one of my favorite projects out of Netflix open source recently, I think it came out maybe last year, it's called Dynamite. It's an implementation of the Dynamo paper, which gives you Cassandra-like semantics, but with Redis or Memcache. And so they're using this pretty heavily. For example, when they sort of offline generate all of their batch recommendations for all of the users, they can then push this out to like a huge distributed Redis cache. It's not using Redis distributed, but it's actually just a bunch of masters that are being controlled by this layer called Dynamite, right? And so that gives you the auto scaling, and there's no disk access at all. So before they were serving up recommendations from Cassandra, right? But they wanted faster, and of course Netflix has lots of money because you all rarely have it now, so you can all pay the €8 or €9, whatever it costs. Yeah, so I think more in terms of caches these days and just the ability to drop partitions and have replicas everywhere, and yeah.
Okay.
I don't actually have anything to add to what people have said, so.
Okay. Then related to your answer, the evolution about the storage, the hard disk, SSD, RAM, how much percentage is going to be of the data in these cached systems with RAM and with memory? What will be in SSD and the other? what's your opinion about this? How is evolving the world? The magnetic or the normal hard disk will be replaced completely in the next years? What's your opinion?
So one quick extension to that model, I was just talking to some of my Netflix buddies, and they finally admitted that this is very expensive, right? To have this, to have what like used to be on, right? Yeah, so they use SSDs, of course, for their Cassandra, but storing all this, and so they're doing these sort of right, like less active users. I think they're using RocksDB to, so it's sort of a combination of right, like Redis and then RocksDB, and that goes to disk, and then once people log in, then it'll, so it's sort of, and they can turn the knobs as to how quickly they should, flush it to disk and things like that. So.
Okay.
Is it like a right behind kind of architecture?
So this is more for just, this particular use case anyway was just more like read-only, right? Just like throwing it out there, and it was just the size of, the recommendations and all the different like permutations and like the item-to-item similarity and things like that. Like so all that stuff for each user just takes up a lot of footprint. So yeah, they would put it back to disk.
Actually reminds me the good old days when I was studying Hennessy and Patterson, the book about computer design back in the 80s. So you know that in fact when you have a hierarchy of memories, it works only as far as you access the data on the closest level. If you start having the so-called misses, so the data actually is not there, then you're not winning anything. So what fascinates me is that, in fact, we are kind of refiguring out the same problems, but at this massive scale of data centers. And the question remains, is still the same. Is actually your locality, so your microservices, are they going to access data which is actually so close that you can benefit from it? Or not. Now, for Hadoop, in some cases, it's proven that locality of data and computing was the actual good thing to do. In other cases, must be actually perfectly logical. So I think it's still a ad hoc decision today, and the application should be tuned for that. I don't know, tools for tuning this sort of memory hierarchies at data center scale. I'm not very aware of it at the moment.
There's a general concept behind that, and I think a couple of you guys wrote about that, calling that data temperature, right? So you figure out, is that piece of data something someone will touch on a daily basis? If not, you put it on Glacier or whatever, because you only need it for auditing purposes every 5 years, right? If it's something that every 5 seconds I need that, I really want to have it like in cache, in memory somewhere. So this is the task, right? So you need to figure out what temperature does your data have, and then maybe disk is the best way, or even I don't know what Glacier is built of, but probably some tapes.
No, but I are seeing some evolution about the infrastructure, the technology. For example, for the glaciers, we were using tapes 5 years ago. Right now, Google is using the magnetic hard disk for that, and maybe in the future, SSD will be for the glaciers, and a special type of memory with will be used, because the research and development in this is going very fast.
I do think, though, we're seeing systems start to figure that out for themselves. Like in Hive, now that we have LLAP in the caching, one thing we're doing is for the cloud, adding an SSD behind that, not to cache into it first, but when we have to spill and we're not sure yet if that data it's not hot, because if it was hot, we wouldn't be spilling it, but maybe it's warm, and we don't want to pay, the next time somebody comes for it, we don't want to pay the round trip clear back to S3 or whatever. So we spill it back there for a little while first and see if does it pop back into the cache. So I think systems are at least starting to find their way toward figuring that out on their own, instead of relying on a human to say hot, cold, warm. Yeah. Which is going to be much more efficient.
Okay, so I think we are out of time now.
Yeah, I'm afraid so. Well, all the speakers are going to be here for later sessions, so we don't have time for questions.
No?
No, I'm really sorry.
Okay.
But there are, bear in mind, there are already 3 simultaneous tracks open, running now in other theaters
okay.
as we speak now. So we need to let these people choose their premises. So Natalino Busa from Teradata, Paco Nathan from O'Reilly Media, Alan Gates from Hortonworks, Chris Fregly from PipelineIO, and Michael Hausenblas from Mesosphere, of course, Óscar Méndez. Thank you very much all.